Hello, I'm Nigel Griffiths. I work in Advanced Technical Support in Power Systems, IBM Europe. In this Director6 for AX movie, we're going to look at VMControl when it's running the image management function, and we're going to capture a virtual appliance. Now, before you attempt this, you have to have a few things prepared. Well, of course, you've got to have Director6 running and VMControl installed. You also need this VMControl agent installed on the NIM server. There's another movie that tells you how to do that. Then for the virtual server or the LPAR that you want to capture, the target, we need a few things set up. First of all, it has to be pure virtual, by which I mean we need to have virtual disks, a virtual network, and then optionally a virtual optical and virtual tape. The logical partition has to be a Director6 endpoint. You've got to have access working for that, and a recent inventory is probably a good idea too. The LPAR also has to be a NIM client of a NIM server, the one being used by VMControl. Also, VMControl is going to contact the HMC and VIO server to get some information about the logical partition, and these also need to be Director6 endpoints, and again access OK and a recent inventory. If you're using IVM, then the IVM server is providing the HMC type functions, and it's also a VIO server, so that will be the alternative for running in IVM mode. We're going to start off then on the user interface. We're going to request a capture of a virtual server, in director terms, a logical partition in our terms. It's then going to contact the HMC and VIO server to get some information about the configuration of our LPAR. We're then going to pass control to the sub-agent in the VMControl that's running on the NIM server. It's then going to make NIM create a makesysb. While it's actually doing that, we'll be able to see the back by name command running. That's the backup command used to generate the makesysb. It will actually be doing that over NFS, so it ends up on the NIM server. And once it's finished, then we'll find that we'll have a makesysb image on the NIM server and some configuration files that include the details that we need to use that makesysb to deploy it later on. And we can actually see the files. We're not really meant to go in there and do anything with them, but you can actually see the files in the export NIM appliance directory. Okay, we're going to do a capture. I've made sure the NIM server is online, and I've made sure that the logical partition that I'm trying to capture is online. Worth reading the information here in the learning more about capturing. Gives you some information. In here now we're going to define what we're actually going to capture, and I'm going to capture a very simple install which has the C compiler installed. Worth putting in some more information in here, perhaps the root password so you can remember it, perhaps the logical partition that you saved, any other information that you actually need about the way you set up the application. In this case it's just a simple C compiler. In here we might put AIX61 compiler. We can use these to help us find the right version. Actually we got it's the VAC compiler 10. We're going to collect that from a virtual server, which is Director6 speak for a logical partition. Well, I'm lucky, it's actually brought up the right list in here. I was previously using Navigate to look at this list. Let's pop this out of the way, and we can add that target up here. Scroll down, we can see the next key. Of course, on a bigger screen you won't have to scroll up and down. It's going to capture the Ethernet. This is a very simple configuration with a single virtual Ethernet, so that's okay. In more complicated network setups, you may have to select the ones you want to actually capture. This is giving me a reminder of what I actually want to do, and we'll click Finish. And we'll do that now. We'll come back to that later on. If you actually got access to your NIM server and your client, then you can actually watch the makesysb happen and that being brought back to the NIM client. Here we can see it running. It's at 40% busy, but if we go and look at the NIM server and the logical partition, we can see, if we go to the export NIM directory, we find there's a subdirectory called appliance here. In here we find some very peculiar files. This is the actual directory for a particular appliance. Great big name. It's not meant to be accessed by us. If we go and look at that one, we can see here's the makesysb image being created, and it's getting bigger. And if I bring in a window which is on the Capture target machine, and we can see at the top here, taking a third to half of a CPU, the backup by name command. This is the backup that makes the bulk of the makesysb output file. And we can see we have mounted from the NIM server, which is Diamond 5, the directory we were looking at before. So this looks good. It's doing the makesysb now and saving that on the NIM server. Okay, 10 minutes later, I wasn't actually measuring the time, but something like that. Capture virtual appliance 100% complete. That looks good. If we look on the client we captured, it's gone idle. If we look at the Diamond 5 by NIM server, we see that there's a makesysb about 2.2 gigabytes. A fairly typical makesysb of a recently installed copy of AIX. In this case, got a compiler on there too. The details of the appliance are in this .ovf file. This is in XML format, and it has the details of the appliance, the name and description, but also the requirements for CPU, memory and disk space. This is used when we want to deploy this appliance to create a new logical partition. And we'll cover that in the next movie.